Hello, welcome back to video feedback. This is all hands on DAQ, part 5. And let's open the slides. It's a good idea, isn't it? Okay, so this section is paired with the interlude real switch, real device. And if they'll actually open, let's get the presenter view up. And there we are. So what we're going to cover is configuring DAQ, so it'll talk to an actual switch, and actually penetration test, or rather qualify a real life device. In this case, it's going to be a DAQ PTU 207, something like that. It's a DAQ controller anyway. So what we're going to do, we're going to have another link to the full network topology, which is essentially a laptop with DAQ running on it, and two USB to Ethernet adapters, one of which is plugged into the data plane of our switch, and the other one which is plugged into the control plane. Just a note on data planes and control planes, the way I think about this, which may or may not be correct, I'm no expert on this, but the control plane is kind of the part of the switch which allows you to, update the flow tables and control the switch. So if OpenFlow wasn't turned on the switch, the control plane is the bit that you would log into to configure the switch. It just so happens that we're running OpenFlow and we're letting Faucet control, the switch through that control plane. The data plane is everything else. Okay, hang on, let me just edit this file to it there. Right. So what are we doing? So we're moving beyond faux devices. So up until now, we've only been testing faux devices, which, as we've already covered, a faux device is a Docker container, which is acting as a dummy device under test. So if we just go back to everything else before we start playing around with the dashboard, and we would just have a look at the faux Docker file. Let's once again get some syntax highlighting. So what the Docker file is, as it stands in this current commit, 902d221b3, whatever it is, we are using aardvark, and we are calling that Java build. So aardvark is Ubuntu with some standard network stuff. We're installing Java into it. We're installing the OpenJDK 8. And then we're fixing the version of the backnet bit of the faux device, and we are loading in Graph News fork of backnet 4j, and then we are, for some reason, installing the JDK again. I don't know. And then we are kind of installing loads of things which make this Docker container act like a web server or anything else that we want it to. So that's kind of the bare bones of it in simple terms. And if we go into the options section, so if we actually look at the thing itself, where is that? Ah, yes, bin start flow. So if we go into bin start flow, maybe not, thank you VS Code. If we go into bin start flow down here, there we go. Then we can see all of the options that make it do various things. So if we go back to our local system conf, which I kind of glossed over before, we've given our current 3 faux containers, our 3 faux devices, various options. So for the first faux device, you want this to have an option brute. For the second device, you want it to have multiple options, one of which is no brute and expired TLS. So we're going to force the TLS test to fail. The backnet failed as well. We're going to give it a pubber, and we're going to force it to fail the password test. So these have been defined by the developers of the tests and the developers of the framework. And what each of those options maps to is an option in the start faux script. So none of these are kind of, well, some of them are if and else if, but this kind of long, effectively a case statement, is just a way to turn on multiple options at once. So you can't have something failing a backnet test and passing a backnet test at the same time. It's kind of like but it's a paradox. It's kind of like a Schrodinger's faux container right there. You never know whether it's passed or failed, and that's not what we want as operators. Same thing as discover, same thing as curl, brew, all that sort of stuff. So that's a quick overview, and run through of the faux container and its options. But that's not what we're here to discuss today. So what we need is a new system.conf, and then we need a way to test our communication channels, and then we need to experience the plug and play aspect of DAQ. So if we just go to this part of the wiki, so we've got using DAQ with an OpenFlow switch. So your switch absolutely needs, there's no way around it, it needs to support OpenFlow 1.3 or above, because Faucet is designed with OpenFlow 1.3 in mind. If your switch runs, we've tested DAQ on switches that run OpenFlow 1.0, 1.1, with little to no joy, and that basically means no joy. So yeah, so as they are wont to do and be very helpful, the Faucet project have provided a list of switches that are supported by Faucet. And generally, if they're supported by Faucet, they are supported by DAQ, with some extra wrangling. As I was kind of saying, well, as I haven't even said that, I said it in the supplementary video. DAQ currently supports the Allied Telesis X230 series, and it supports the Cisco Catalyst 9300 series. Faucet will work on things such as the Zodiac FX, Zodiac GX, and it'll work on OVS, Open vSwitch, which is how DAQ operates in local mode without switch connected. But as of now, Faucet and DAQ only work on Allied Telesis and Cisco switches. So it's kind of out of the scope of this series to explain how to set up each switch, but generally it involves logging into the switch and setting up various VLANs, turning on OpenFlow, disabling spanning tree stuff, etc., 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 and setting an IP address and a data path ID, aka a DP ID, for OpenFlow and Faucet to communicate via. Okay, and there's a similar story for the Cisco switch as well. But without further ado, let's just go through how to set up the movement beyond the phone device. Okay, so a nice example is included within MISC. So if we have a look at system.conf, which is an example, so if we do system underscore phi, so yeah, system physical, it's kind of a contraction of that, then basically what we need is all of this stuff. So I'm just going to copy this into our system.conf, and I'm going to label this bit physical switch configuration. I'm just going to call it config because it's a configuration loads of times. Okay, and most importantly, I'm going to get rid of our MISC startup multi command, and I'm going to get rid of that. I'm also going to get rid of this upstream sec port thing here because we're going to redefine it down here. Okay, so if we change this to all hands on DAQ, real switch, let's do some colons, why not? Real device. Okay, save that. So if we have a look in, what have I changed there? Package log, that's right. So back into our all hands on DAQ directory, if we have a look at ifconfig, we see that we have two new network interfaces. Now I happen to know that the ext control interface is the one that ends 7E right here. So I'm going to put that in there. I'm just going to put a little comment through each of these things just as I go along. So the sec port down here, that is the data plane. So that's the port that we've allotted on our switch as the data plane. And I've set up this Allied Telesis switch to this data plane is on port 15. That's what I'm trying to say. The external OpenFlow IP, OpenFlow IP, I think, and then there's an external OpenFlow port port, and that is essentially what Faucet will talk to. So Faucet normally talks over TCP port 6653, and we have given the data plane, the control plane, excuse me, in our allied solution switch, give it an IP address of, or rather a range of 192.168.1.10.24. So that's our range. And then, so this is where it gets confusing. I start mumbling over my own words. So the IP address that we've given Faucet to talk to is this extra address here. And that is the address that we're going to try and, well, we're going to test that we can actually reach this address. Because if we can reach this address manually, then that means Faucet can reach it, and that means DAQ can work. Then, execute flows and all that lovely stuff. And I've set up a data path ID on this switch of 42 because Douglas Adams, and thanks for all the fish and stuff like that. So the external interface, that I happen to know is this one that's B3, so I'm just going to copy and paste that one there, and that should be all we need, apart from the fact that we need an external low IP. So we've seen some results from the switch tests, and they've said that there is no local IP set, and this is the local IP that we're setting right here. It's kind of an amalgamation of this external address and this address and all the other addresses that OpenFlow needs to communicate properly. Let's get out of this. So now what we're going to do is test that. So hopefully there's a script included within DAQ to test that our switch is connected properly. Let's just have a look at that for a second. So if we go into bin and then physical sec, this is kind of what it does. So it cleans the switch bridge. So it does some stuff with Open vSwitch. And if external control, so that'll be that, if it's not defined, then it won't do anything. Similarly, if the external interface isn't defined, then it won't do anything, even though we've got a slightly confusing comment here. Same for the external interface. So for the sake of argument, let's just comment that out and run this script. Oh, there we go. It's going to be required to run the sudo again. And it's going to say, x.fp. So helpfully, if you don't configure it obviously enough for DAQ to pick up your configuration in your system.conf, then that script won't work, and I'll tell you why, which is good. So yeah, so I've just done that script, and it's pinged the extra address, which is what we set up on the switch, to communicate with Faucet via OpenFlow. And generally, if this succeeds, and it says done with physical switch configuration and DAQ ortogon IP link set down, then you're ready to go. If it doesn't succeed, this will happen. So if we just set this to 192.168.1.5, which is the wrong IP address, then we'll run that, it'll try and ping it, and then it'll say that didn't seem to work. This is the exact, so if we try and run DAQ with an incorrect external switch configuration, and we try and run command run -s, as we have been doing consistently, then that same script will be triggered, and it'll say the same thing. That didn't seem to work. So the bin physical sec script is lovely because it can be run standalone or it can be run within DAQ. Okay, so let's just run DAQ and see what happens. So we still got our dashboard set up. So we will monitor what is happening on our dashboard. And at the moment, I've got a device plugged into, I believe, port 8. And it's the Distech device that is shown in wonderful Technicolor in the interlude video. Interlude, real switch, real device, or real device, real switch. I can't remember which way around it was. But we can see that port DPID66 is now active, true, which fills me with slight amount of horror. There we go. So it's appearing on a dashboard. Now, I'm not sure how many times this device has been tested, and it could be that if this device has been plugged in for absolutely ages, there could be something going on with DHCP. But, as it turns out, there hasn't. So, right now, DAQ is prepping. There we go. Startup is done. Sanity is done. And now we're waiting for DHCP. So this is the true test. Well, it's the first of many true tests. Ooh. 18 seconds, 19 seconds. There is talk on the forum of adding in a generic timeout for each test, because sometimes DHCP can take a very long time. And if you're running multiple devices at once and this DHCP test takes, I don't know, 4 hours, then obviously it's not passed. And there's something going wrong. But let's see, because sometimes it can take a good deal of time, depending on how you've got So there's another thing here, which is the kind of test config, hard to say, which applies this long wait script to the runtime. So, as it turns out, DHCP is working, and we have a test. This is all good. So, Faucet and Faucet through DAQ have given this device an IP address of 10.20.16.152, as we can see here. And if we once again run our doc IP command, I was running the doc IP command just after DAQ had finished. So interestingly, something failed. And I wonder why. Smudgy. So I feel like something failed. I'm not entirely sure why, but we can kind of debug it. So if we go in our ints folder, make sure, if using VS Code, which there are many other text editors out there, it just pays to do this refresh thing if you're doing multiple runs, because sometimes what you see can be slightly out of date. So if you look at run port 8, then we can kind of see that something has gone drastically wrong. So at this stage, because I've been running DAQ locally initially, I'm just going to do a command, and because now I've just plugged into physical switch, some networking things could be left over and some networking things could be dangling and snagging on our progress. So I'm just going to do a command clean, command build, and command run. So all of those things are just going to get rid of absolutely everything, and it's going to build everything again from scratch. Okay, but yeah, in general, that is how we run DAQ on a real open flow switch, which basically amend the system.conf. We run the bin physical sec script, which will still work even while the Docker build thing is running. Let's run the passwords. They'll still work. But just be careful of things becoming out of sync if you're changing operating environments. And what we'll do is we will actually close that down. I'll do a command clean again. We're just going to do a quick rejig of our configuration, because one of the most interesting tests in DAQ is a test that tests. A test that ensures the device is drawing power over PoE, power over Ethernet. So we're just going to go into, let's delete this site 2 thing, unless we're using it. We're not, are we? That was site, no. So let's delete the site 2 thing. And we will put in the switch test into our local tests. So let's just reference the all tests. Let's put this back in here. switch test. And let's once again do a clean and command build. Okay, perfect. And we'll come back when that is done. Okay, so we're back, and the build hash has been updated. Sweet. So we will. Oh, will I? Just got to watch DAQ. No, of course I haven't. Source. There we go. So we will run DAQ once again with our new build. So remember, we have enabled the switch tests, and contrary to what I was saying before the build break, the tests we're actually going to run our tests on a different device because I realized the DiskTech device isn't actually PoE. So the device we're testing is a Delta controls device, which is definitely PoE. So at the moment, there's nothing at all plugged into the switch, and I'll just record a video simultaneously. So let me just crank up my phone for another supplementary thing. Try and do it in parallel. So, okay, we're taking the cable, that's what we're doing, and then we're going to plug it in. So sorry, plug it in this side, and we're just going to plug it into this here. So we're going to plug it into ETH1. So this device has been set up correctly. Click, has been set up with DHCP, and we can see that it's kind of powering on. But what we'll see on the dashboard when we do that, when the little mounted thing goes from green to red, hopefully, unless it's just very, very slightly out of whack. Sometimes with these, that's okay. Okay, so we can see that we're already testing. Okay, so yeah, state symbol has gone there. We can see with our cable, with our beautiful Ethernet port flashing light, so that data is being transferred. So we just pause that. And we can see on the dashboard that things are happening. So it's been allocated an IP address, and we can see DAQ's doing some stuff. Waiting things to settle, and DAQ runner has returned 0. DAQ has run exit code absolute 0. Still getting this monitor error. So the next video was going to be entitled Troubleshooting, but I feel like this might come slightly early. So what's happened? Aha! What we've got it here. We've missed out our switch model configuration. So what we have missed is, yeah, so thankfully that gives us some quite informative error messages. So we need, just literally copy and paste that from there. We need a little option in our system.conf to set things up so that DAQ knows which switch it's testing against. So X230, let's do that. Okay, so that clean build run step was kind of useless, but no worries. Let's just do it again. Alright, so we've got communication with the switch, it's all happy. So we've got the tests configured: backnet, Mudgy, mmap, boot, discover, and switch. And if we refresh the dashboard again, then when it kicks in, yeah, we should have it. Yep, we're initializing. This is all good. Okay, so while that's happening, I just want to go through what happens if you click here, first of all, and then what happens if you click here. So if I click on the MAC address, I can see the configuration of the device. Now, I haven't actually set up a specific configuration for this device. So if I'd included, so the MAC address for this is, well, let's have a look on the dashboard, see the power of it. The MAC address for this guy is 004, etc. So if we had a module config not in the orgs folder, but outside here, then that configuration would appear to edit here. So what you can do is you can add keys here, and you can append stuff, and you can you can make things from scratch, and it'll say saving. But we're not going to do that because it'll take too long. And if you so here we go, map error discover. Blah, blah, blah. If you click on port 8, then you'll see, as we covered before, a history of what's happened on this port. So because this is a fresh Firebase instance of DAQ, we've tried to test this device 3 times because I messed it up a bit before. Or rather, actually what's happened is we've plugged in a device on port 8 a couple of times. So we can see there's different MAC addresses here. So this 74 thing was the DISTech device, and 0040, etc. is the Delta controls device. That's fine. And once again, if I were to click here, then I can see the latest configuration. If I do this while DAQ's running, then it should update to something better. Because you should be able to edit it down here in the configuration definition. Because this is kind of a runtime config kind of thing. Okay, starting faucet. Let's do it. Okay, beautiful. I'm just going to do another little live video of another device. There we go, say port A initializing. Another device being plugged in. So I'm going to go over here, and I'm going to very quickly find another Ethernet cable. Am I? Maybe I'm not. Disaster. So I absolutely am going to find another Ethernet cable. I'm going to plug that one into there. I'm going to trace this really quickly. I believe it's that one. And I'm going to plug this guy into port 5, like that. We should see port 5 initializes straight away. So that's the kind of plug and play aspect of DAQ. It's a simple kind of thing for a switch to detect when something's plugged in. But it's quite another thing to plug in a device and then have DAQ start running tests on it straight away. I mean, I think that's quite impressive. I hope you agree. Yeah. So that's kind of all good. So we can see we've got things going, we've got Mudgy running, and yeah. So if I click on here again, maybe I'm mistaken. There we go. So while DAQ is running, we can see that our configuration definition is displayable in the configuration editor. And if I were to change Discover to enabled right here, enable that to false, save changes, it's a saving for a while, and then if and only if DAQ hasn't finished, or maybe it's already finished. It's kind of a window in which you can change the configuration. Yeah, it finished. There are other settings in DAQ where you can hold, well, you can add a hold test, number one. So the operation of, the flow of DAQ tests is halted for a bit, so you can change configuration stuff and then trigger it again. But yeah, that's probably for a different video to exhibit that. So yeah, here we can see we have a report for our device 7 whatever, which is our DISTech device. The discovery test has found out that it is a BACnet device, which is all good because we've got port 47828 open. The vendor ID, DISTech controls, vendor name, DISTech controls. We've got a firmware going in here, and we haven't actually set up anything to do with this device to test what version of the firmware we're expecting. But even so, it's a result of info that tells us what's going on. The mmap test, basically ports 80 and 443 are open, but we haven't defined anywhere that they're meant to be closed, so that's going to fail. We haven't defined anywhere they're meant to be open either. So okay, so this overall device result is a fail. And as ever, if we look in either our local or our inst folder, So if we go in here, then we can see a device report.pdf. Open anyway, yes I do. Which is the exact same thing. And we can see the same for our Delta control device here. So that's all good. I just want to run through quickly how you can fill up some of these things at the top. So if we go back to our kind of configuration discussion earlier, and we look at a device module config.json. So we're just going to copy and paste this, and we're going to plonk that in for our Delta control. Yeah, for our Delta, well, for our disk device, let's do that one. So let's actually just going to copy it there. No, imagine. Device module config. Let's copy that, and let's put that. There we go. Got to do the own all thing again. So we just do a quick own all. We should be able to paste that in there. Put it in the wrong place, of course. Yes, I'm sure. If we rename that module config.json, and if in the GUID we put something like dead beef, and then we do, I don't know, ace cad, I don't know, network hostname, distech is tested, make distech, and then the model number. It's currently upside down in my so it's hard to read, but let's just put PTU 207, put the name, all hands on DAQ device under test, serial number, let's do a cheeky 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then let's put a firmware version in completely different to the one we found in our report. So let's put 5.6.8.342.0 for no reason whatsoever. And let's find an image of our device. So let's do distech PTU 207. Yeah, I think that's what it is. Let's have a look. That looks about right. So let's open that image in a new tab. And let's just copy the link to that image there. And let's put that in our device image URL, because it shows the real power of the PDF report. The device description is something great, and the device datesheets URL, for the sake of argument, I don't know who I'm arguing with, but let's just put google.com, or rather example.com. And let's keep all this standard stuff up here, but let's allow the backnet, and let's put process attempt number 4, something like that. Cool. And then let's rerun our test. Let's see what happens. Beautiful. So up and running, all good. Yeah, I just wanted to highlight the switch test as well. So if we have a look at our PoE test, ooh, see here, this is interesting. So this is one of the foibles that comes with the I don't know, the cascading configuration. So in our module config here, we've got absolutely nothing. In our module config here, we have the switch test enabled true. For some reason, our switch test is being disabled. That's because we've disabled it in our base config. Let's just finish that for a second. Let's kill that, and let's enable the switch test. Let's enable the PoE. So we should run backxt. I think we built that. MacAY, mudgy, mmap, password, and discover. should be true as well. And let's see, let's change our process in our approver as well. Let's change the approver to, well, let's change it Larry. Change it to Larry Wall, and let's put our approver as, I don't know, the guy. Guido Van Rossum. He should approve things, I reckon. Let's go there. So, running, communicating with our switch, setting up things, and hopefully that should have enabled our switch test. I've forgotten the URL, thankfully. DAQ supplies it for us. Or does it? There we go, that's our DAQ. Initializing. Have we lost network connectivity? It's likely. No, it's good. And we're still testing things. So now, this is the MAC address of our DISTech device. If you open this in a new tab, you should see, there we go. So we've got a device data URL, example.com. It's got a star in the end, which is not that good. Have I accidentally put a star there? It's very likely that I have. Ah, perfect. Let's see if we can change that on the fly. No, we've got some time. Yeah, there we go. So if I do that, and I add in a couple more 8s or something, I save it, then on my local machine, that has been changed. So if I change this back again, save changes, then again on my local machine, it has changed. So that's the link between the DAQ dashboard and the configuration, which you can change at runtime, which is another great little thing, which is a lot more impressive if you do it in the context of real devices. So now we can see that the switch test has been enabled here for both of these devices. Perhaps this DISTech guy might have received too many DHCP requests. You never know. We can see the switch test is running. Ah, no, good. DISTech got itself an IP address. Brilliant. I mean, for me, watching the dashboard is kind of a bit of gamification because there's loads of colours, and I don't know, it's kind of like watching a dashboard of Skittles. It's great. So if we have a look at the Markdown report of our completely unconfigured Delta Controls device, then we can see that we now have some results from the module switch, and we've got the linkers up. So these the commands that are being run to get these replies are allied to Lisa specific kind of telnet commands. So that is why currently DAQ only supports the allied to Lisa and the Cisco 9300, because we've only added in those specific telnet commands to get all this stuff back. So you can see that we have all of these lovely Ethernet related and switch related settings enabled or disabled. And we can also see that some power is being drawn from the PoE line. Specifically, what I'm hoping there is about 3 watts, which is good. So if we just close that one down, now we can see that on our report for DISTech, now we have some results there. For some reason, whatever that reason might be, it's not getting our configuration through. Because what we should be able to see here is all the stuff that we put in before. What I suspect is that we haven't added in the correct report template, or that something has changed since I was last running DAQ. So let's just copy this. Oh, bloody hell. Let's just copy this report template down here, and let's put this in our local folder. Because if memory serves, let's just, for some reason, put it in site as well. Let's fight fire with report templates. And let's once again do our command run s. And let's unplug the Delta controls device just so things run a little bit quicker. But yeah, this is quite a nice example of changing configuration from the dashboard, and also a nice example of enabling and disabling tests. Okay, this is all good. Okay, port 5's up. Let's get in there. Or is it? Maybe this is the limit on this particular device's DHCP requests. Tell you what, let's just unplug that device from port 5 and plug it into port 7. Seems like a good idea. Yep, so there we go. So we got port 5, that should say something like term. Logged into, don't miss port 7. Okay, back in the game. Right, we're pinging things. This is good. So we've got DHCP, and we'll see how it goes. Yeah, I'm suspecting that it's using a very baseline report template, and it's just not injecting in device info and what have you. I believe the report template is in. There you go. Mmap's running. Wonderful. Yep, discovers up. Having said before that I like to use just the dashboard to monitor DAQ. It's kind of a flip-flop between the terminal and the dashboard itself, especially when you're recording a video such as this. Okay, there we go. So port 7 has completed, port 8 completed. I pulled the plug after it finished, that's all good, and DAQ has exited with exit code 1. So, all being well, in the reports, there should be a report for this guy. Refresh again. There should be a report for our disk tech device. And, aha! There we go. So there we are. That's because you need the report template back in. So we have a device. We've given it a name of disk tech PTU207. Got some test roles. Operator, it's the lovely Larry Wall. And the approver is the lovely Guido van Rossum. Those roles could change over time, I'm sure. Test iteration, DAQ version 101, tech number 4. Device identification. We want a firmware version of 5.8.342.0. If the firmware version is different in this ridiculous contrived example, then we're going to assume that this device should not be on the network because the firmware version could have been tampered with by some sort of bad actor. You never know. GUID is this, and then the type we've just left blank. No, that's fine. If we scroll down, then we have a lovely picture which has been extracted from the URL we provided. Because this is now a PDF, that picture is now baked into the URL. Because, excuse me, mixing my words. Because we provided the URL, this image is now baked into the PDF, so it's become persistent. The device documentation, we can look at example.com, which is the site we all know and love. And we have an overall device result of a fail. So mainly because we've failed all the PoE tests, and our discover test, which should have run, perhaps it didn't. Is that? Yes, so there we go. So we're in the module, or rather the test security.firmware, which is in the module discover. We've discovered a firmware version of 1.14.179.1, and the firmware version does not match. So that is an outright fail. So okay, so that is moving beyond faux devices, and we've covered a new system.conf for putting things in like the control interface and the external IP for our control plane, and we've gone through the first of many troubleshooting things to include the report template in local site. Otherwise, all of your lovely images and what have you to get in the PDS will not be inserted. Which also means you can have different report templates which don't include images or include extra things. And you can define those yourself if you do so desire. Okay.